Let's check how all of this information about the MMIO controller and the different I/O cores and the wrapping circuits come all together to construct this particular version of the prototyping system. So we go to Vivado and see that here. So in Vivado, this is the Vanilla F Pro. We have basically a header file here, and if we open that header file includes all information about the different slots that we actually have. For example, we have the timer connected to number 0, UART. This here specify more than what the vanilla actually specifies. In the vanilla, you only need the first 3, but it doesn't hurt if we actually specify the rest, because we will use it in a different system. The same goes for the video subsystem here. These are very useful for the video subsystem, which we're going to cover later. What's more important and more relevant to today is actually the bridge base, and this bridge base comes from the documentation for the microblaze. If you remember from a previous video, this actually tells me it's C0000. This is basically what I'm connecting the bridge. You can definitely move it and everything will move based on this here, but you need just to remember to change that particular base as well in the C code. In here, we're just visualizing how the hardware code is actually implemented. So if you open here, you'll see that there's a one top file, and this top file, if you double click on it, it actually instantiates the processor and everything in here. So if you take a look at the file in the sources, it actually instantiates the processor, the bridge, and the MMIO. So let's take a look at that. This is the inputs and the outputs. And again, because the whole subsystem in here, the switches should appear in it because this is the top file that we implement on the hardware. It does see the bridge base, for example, and we're passing it as a parameter. We have some sort of a reset for the processor because the processor needs a reset. There's the LEDs. The RX and TX are for the UART, which we're going to see later in a different module. And in the rest in here, we do see the I/O bus and a few signal declaration. What's most important to me is actually the instantiation of the microblaze, the instantiation of the bridge, and then the instantiation of the whole MMIO subsystem. So let's take a look at the bridge, and in here we look at the bridge, and the bridge is exactly what we've seen before. It just basically maps the signals 1 to 1 basically, more or less, except for maybe the chip select. It just does a little bit of logic, but the rest of it is just mapping or setting the IO ready to 1. The MMI subsystem is actually more interesting, and you probably can see it also in the figure in here. There's a bunch of file hierarchy. This is why I'm showing it to you here. But again, you take a look at that. I'm going to double click on the MMIO. This is the whole MMIO subsystem all together. And if I take a look at the files, on a top level file, it has the controller, it has a timer, it has a UART, it has a general purpose output, and it has a general purpose input. And the UART has internal files into it, but we're not going to go to it now. So we'll take a look in here, and what we see is actually exactly that. It's actually instantiate the MMIO controller. It instantiate the timer, and actually gives it the different read and write and connects it. It also connects the slot in here, and it connects that, and so forth. So we see that. What's more interesting is in here. So the MMIO controller supports up to 64 slots, but what we do in here, we're just gonna, for the ones that we don't use, we're gonna be using the generate for loop to actually connect just a bunch of ones. It just says, the comment says zeros, but these are just a bunch of ones to it. Okay, we take a look at the MMIO controller. It's actually the same standard controller, and it's actually broadcasting to all 64. Okay, you don't have to you broadcast it, and then in the top file in here, in the top file in here, just go through this generate and just connect them to ones. So now if you want to add another core, for example in a slot number 4, for example, or something like this, you basically take this 4 and make it into a 5, and you continue from there, and you instantiate that fourth IO core. So this is the beauty of using the SoC in here on the FPGA, because it's pretty flexible. If you buy a microcontroller, you can't do this. You can't just add willy-nilly whenever you want, just add another IO core or whatnot. You buy the microcontroller, it has these IO cores. You can definitely turn them off, but they're there and you can't do anything about it. But here, you can definitely say, well, you know what? I don't think I need anything with the LEDs with the outputs. You just take it in here. You just basically remove this line or this instantiation, and that's it. The general purpose output is out, and it's not part of your system. Of course, you're going to have to just track and remove their drivers and whatnot from the C code, but you get the idea. You can just remove it. Okay, so that's pretty much it. It's pretty straightforward. This is the same with the GPO that we saw. This is the same with the GPI, because they're all instantiated in here. And this is the most interesting part of this instantiation, which is basically that. which connected to all the unused slots in here.